of an arithmetic series is it's the sum of the terms of an arithmetic sequence. And if you think back to what we talked about yesterday, a sequence is an ordered list of terms. So today what's going to happen is we are going to add those terms together. Sum, S-U-M. It's the answer to an addition problem. And what we specifically did yesterday when we looked at some examples, by the way, we're in the right-hand column on our front page of our notes, is we said yesterday that a sequence, we had 2, 4, 6, 8, 10. So going along the same lines here, we're going to do 2 plus 4 plus 6 plus 8 plus 10. The only difference with the series is that we add these values together. That's the only difference. Our other example that we did yesterday is we said negative 21, negative 18, negative 15, negative 12, but we're just going to add these together. That's the difference. The sequence is a list of terms. The series is a bunch of the terms added together. And we could still, with our non-example, write a series. We had 4, 8, 16, 32, 64. It's not an arithmetic series, but it is a series, and we can still add those values together. But one last time to stress, when we're working with the series, we're adding the values in our list together, and the sequence is just a list. But as we flip over here to our rules and formulas here, today we're going to concentrate on this formula, and once again, you're not expected to memorize this formula. So we will provide the formulas for you, but let's look at what this formula is talking about. The first value, S sub n, it's a subscript. It drops down just a little bit. This means the sum of all terms. How many terms we have? We're going to add them together. A sub 1, like we talked about yesterday, what did it mean yesterday? Jordan? It means to start. It's our first term. And A sub n is the nth term. And for the most part for us, that's going to be our last term. And finally, what is n? Well, it's how many terms we have. Again, if you were absent yesterday, you might want to refer back to the arithmetic sequences video. But we had a lot of these same abbreviations yesterday. And let's flip over our paper a couple of pages now, where it says arithmetic series examples. So what are we really doing when we're working with an arithmetic series? That's the question here. So again, an arithmetic sequence is one in which the terms differ by some constant amount. We're now looking at adding these terms in the sequence, and this is referred to as the sum. Again, S-U-M, which means answer to an addition problem. The sum of the terms in the series or sequence. And the notation that we use, we just saw it on the front of our paper here, is S sub n. that n drops down like half a space on your paper. It's a subscript. It's defined to be as the sum of terms a sub 0, the first term through the last term in a sequence. So if we look at this first value here, this sequence, 4, 10, 16, 28, 22, 28, and so forth, this notation over here says S sub 1. What that means is we are going to add together one value in our sum. Well, the only thing that we can add is that first term there, which is 4. So S sub 2 means that we're going to add together the first two terms. So in this one, we're going to take the 4, and then we're going to add it to 10, and get 14. And you might see the pattern already. Sum of 3 values. Well, that means we're going to take 4 plus 10 plus 16. And you can type it in your calculator if you need to, but we get 30. So sum of 4 is 4 plus 10 plus 16 plus 22. The first term, the second term, the third term, the fourth term, and we get 52. So if we sum together all 5 of the terms that are listed there on our paper, what we're going to do is we're going to do 4 plus 10 plus 16 plus 22 plus 28. And when we do that, what we end up with is 80, which you could type in your calculator adding those together. The thing is, after about 5, it might get to be a little bit tough. So what we're going to look at today is we're going to look at the formula that we just saw on the front of our notes to help us come up with the sum rather than write it out by hand. Because the last thing that we would want to do is if we had to add up 100 numbers, do we want to type that in 100 times in our calculator? And maybe some of you are saying yes, but for the most part, the answer is probably no. So if we take a look here at this sequence, what you might, well, we'll write it down here in a second. Given a sequence, 2, 10, 18, 26, and so forth, what is the common difference? Well, just as a reminder here, how do we find the common difference? We take 10 minus 2, and we get 8. Or we take 18 minus 10, and we get 8. Or we take 26 minus 18, and we get 8. That value of 8 needs to be the same consistently, and that is called the common difference. I didn't leave enough space on my paper, but I think if you write out to the right here a little bit, you will be fine for this next part, because the next part says write an equation for the nth term. This is what we did over and over and over yesterday. So the first thing I'm writing down is the formula, which is a sub n equals a sub 1 plus n minus 1 times d. What this means, the nth term is the first term plus how many terms we have minus 1 times the common difference. And when we look at what we have here, our a sub 1, the first value in our sequence is 2. Our common difference we just found is the 8. And that's all we know on this particular one. But we're going to fill in our equation. Now we get a sub n equals 2 plus n minus 1 times our 8. going to distribute. So we get here and here. So we get 2 plus 8n minus 8. What's outside the parentheses gets multiplied by what's inside the parentheses. When we combine like terms, we get a sub n equals 2 minus 8 is negative 6 plus 8n. And now what's going to happen is we're going to use that formula. So even if you infringed on your space there in your notes, we're good. Because now what we know is it says, what is the 15th term? That means that n is 15. So again, people who were absent yesterday, this is probably looking foreign, but this is what we spent our time on yesterday. So now what we're going to do is we're going to go back into this formula that we just created. So it's a of 15. And then we have negative 6 plus 8 times 15. And we can go ahead and type that in our calculator if we need to. Negative 6 plus 8 times 15 gives us 114. So now, how do we take it to the next level here? That's what part D is. It says, what is the sum of the first 15 terms of the sequence? There's our new formula now. Sum. It's going to be n divided by 2 times the first term plus the last term. In this case, it's going to be the 15th term that we're going to fill in. So when we do, look at what we've got. We've got all our information right here. We just need to put it in. And even though I didn't write it, I'm going to write it right now. Should have written it there. That's our A15. 114 is our 15th term. So we put this value in and we get 15. Here's our n, divided by 2, times our first value, a sub 1, which is 2, plus a sub n, which is 114. That's what we just found. And again, we can go back and we can type this in our calculator. So we've got 15 divided by 2 times 2, first term, plus our 15th term, and we get 870. What does that mean? That means that if we added 2 plus 10 plus 18 plus 26 all the way up to 114, we'd have 870. And again, since it's only 15 terms, we probably can go 2 plus 8 plus 10 plus 18 plus 26, whatever the values are there. I got an extra one in there. 2 plus 10 plus 18 plus 26. But once it gets much higher, it gets harder to do. And that's why we have the formulas here, which is what we're going to continue to practice. Integrating in what we did yesterday. And that's the first example. So that familiarizes us with the process, but you probably aren't going to go home and go, oh yeah, I totally know what I'm doing. So we need to practice some more. So let's look at our next one here. Again, a series. It's a list of numbers that are added together. 26 plus 29 plus 32, all the way up to 212. We want to find the sum of this series. And so off to the left here, let's write down our formula for sum. which is n divided by 2 times a1 plus an. And then, let's divide that up a little bit. And let's remember what our formula was that we used yesterday, because if we look over here at our hint, it says find d and n first. So we need a formula with that in it, and that's going to be our a sub n equals a sub 1 plus n minus 1 times d. There's that formula, and let's put in a little dividing bar there. And off to the end. Let's list what we know. Help me out. What's a sub 1 in this problem? The first value. Anybody? Bradley? Oh, Oscar, was that you? Nice. 26. There's our first value. We know a couple other pieces of information. Anybody have any idea? What else we know? Bradley? How'd you get d equals 3? And you can't hear him very well. 29 minus 26 is 3. 32 minus 29 is 3. We do happen to know one more piece of information. Hayden? One more time here. I got Mr. Carr over here too. I can't hear him. N. And it's actually going to be that AN is 212. We don't know what N is. But now that we've got that information, we can find N. And we're going to go back into our second formula, the one that we used yesterday a lot. So we can fill it in. 26 plus N minus 1 times D, which is 3. And that's going to equal our 212. So we need to solve that. That means that we're going to use distributive property again. Here. So we've got 212 equals 26 plus 3n minus 3. Combine like terms. Well, we get 212 equals 26 minus 3, which is 23, plus 3n. What do we have to do to solve this equation now? Jordan? Subtract 23. So we're going to subtract 23 on both sides. And let's see, 2 minus 3, 12 minus 3 is 9, and 20 minus 2 is 18, but boy, equals 3n. And finally, 3 times n, the inverse operation is to divide by 3. And we get n equals 63. We need that. What that is really saying here is that a sub n is really a sub 63. And therefore what that means is that n equals 63. I'm so sorry. So now, I just got n equals 63. Now we can go back over there and we can fill in the rest of it, because we needed to know that value. 63 divided by 2. We already knew the other parts. We knew our a sub 1 is 26, and our a sub n, what color is red? It's 212. I'm going to type it in our calculator. That's finally going to get all of these values added up, and it's probably going to be a pretty big number. So we can take 63 divided by 2 times our 26. Let's do 12. We get 7,497. Let's have you try this one on your own for a moment. And I'll get you going in the right direction with the formulas here. What we want to do is we want to find our sum. So it's going to be n divided by 2 times a sub 1 plus a sub n. But if you look here, we have to do the same thing that we had to do with the last one. Hint, find d and n first. So we're going to have to find here. We're going to have to use that formula so that when we figure out what n specifically is, then we can figure out what the sum of these are. So over here to the far right, you want to identify what a sub 1 is, d is, and a sub n is to start. And I'll pause the video. Same kind of idea here on problem number 5. We want to find the sum of 13 terms here. And once again, our formulas that we have, our S of n is n divided by 2 times a1 plus an. And the only question is are we going to need that other formula that we were dealing with yesterday, which is our a sub n equals a sub 1 plus n minus 1 times d. And let's see what we know. What's our first value? Matthew? Negative 7. And then common difference. I'll stick with one color here. Well, if you get confused with the common difference, by the way, that's what the calculator can help us with. We could say negative 4 minus negative 7 gives us 3. Let's try the next one. Here, negative 1 minus negative 4, we'll still get 3. So our common difference is 3. We want to find the sum of 13 terms. That means that n is 13. That's the hard part, if there is one. That's probably the hardest part. So the question is, do we need to use our formula from yesterday? We do. We need to figure out what is that 13th term. So over here, we've got a sub 13 equals our first term, negative 7, plus n, minus 1, times 3. You can type this into your calculator. I'm going to do the math because I think I can do it faster than I can to type it in. 13 minus 1 is 12. 12 times 3 is 36. And so negative 7 plus 36 then is 29, which is our a sub 13. We need that value because, again, this is a sub n. So we're going to take that value of 29. We know everything else that we need to know over here. We know that n is 13 divided by 2. We know our a sub 1 is negative 7. We just found out that our a sub 13 is 29. And now we can type that in our calculator. And we end up with 13 divided by 2 times -7 plus 29. Is positive or negative? Positive. Positive 29. Oh, gives us 143. And at some point, I bet some of you are already working ahead of me here. But we get 143. What I hope that you're seeing here is, in terms of a process, is that on almost all of our examples, we've set this up where we have our sum, we have our nth term formula, we have the information that we know, and then we use it to put it back into the formula. So if we look at example number 6 here, it says in an arithmetic sequence, the first term is 8. Oh, that's nice. We're given that information. The common difference is 3. That's nice. We're given that information. We want to find the sum of the first 10 numbers. So when we start, let's set up our formula. A1 plus A sub n. We know we're going to need that because the question says find S10, the sum of the first 10 numbers in the series. First 10 numbers added together. Question is, will we need the A sub n equals A sub 1 plus n minus 1 times d? And write down what we know. We know that our first term is 8. We know that our common difference is 3. What else do we know on this one? Jordan? What's n? N is 10. The sum of the first 10 numbers. Sum of the first 10 numbers. If you're not sure where that came from. So we know a lot. We can put the 10 back in here in our formula. We know our A sub 1 is 8. We don't know what A sub n is, and that's when we have to go back and use this formula again. So a little bit different approach there, but as we fill this in, it's going to be 8 plus 10 minus 1, n is 10, times 3. Again, you can type that in your calculator, but I think I can do it faster without. 10 minus 1 is 9. 8 plus 27 then is 35. And once we combine that here, we can put the 35 back over here. And we can type it in. And the thing is, too, maybe it's easier for some of you, is 10 divided by 2 is 5, and 8 plus 35 is 43. That's a little bit easier to type in, especially if you don't have your graphing calculator with you today. Because some of you are using your phone calculator, and that's fine. But it's easier to type that in, so we get the 215 for our sum of the first 10 numbers. But as we finish here, let's skip number 7 and look at problems 8 and 9. So it says consider the following arithmetic series. So we're given a series. Again, series means that we've got a list of terms that are added together. The question is, how many numbers are being added here? Do we need this formula? Do we need that one? Well, we've got it written down. our other formula is that. And let's look at what we know. And then we can go back and we can figure out, do we need them both? So, what's our case of 1? Anybody? Got it? 250. And then, common difference, we have to figure it out. Gordon? It's going to be 7. And let's just look at our math here for a second. It's 243 minus 250. What did we forget? It's 236 minus 243. So we forgot negative 7. That's what we can use our calculators here to help us figure that value out. We know one more piece of information here, and this is the hard one on here. Matthew? It's AN equals 47. Close. So now, let's go back and use our formula here. Fill it in. 250. We don't know N. We know our D is negative 7, and be careful because we're going to have to distribute a negative. And over here, it's going to equal to 47. So now, we're going to distribute here and here. So we get 47 equals 250. Negative 7 times N. Negative 7N. Negative 7 times negative 1 is positive 7. We can combine like terms. 250 plus 7. We get 47 equals 257 minus 7n. Subtract 257 from both sides. And when we subtract, we get negative 210 equals negative 7n. And the question, remember, is how many numbers are being added here? Well, when we divide by negative 7, we get the n equals 30, which tells us how many answers are being added here. The question isn't asking what is the sum. It just was how many. We don't need to use that first column there in this particular case. As we finish here on this last problem, in her garden, Jenny has created a brick mosaic in a trapezoidal shape. So just in case you forgot, here, there's roughly what a trapezoid looks like. Very rough sketch of that. And it says the mosaic pattern has 6 rows. The first row has 8 bricks in it, and the last row has 24 bricks in it. And it says, given that Jenny's pattern follows an arithmetic sequence, how many bricks does she need? Well, what I started off with here is I started off with first. The first row has 8 bricks in it. We don't know the second row, we don't know the third row, we don't know the fourth row, we don't know the fifth row, but we know that the sixth row is 24. And in this particular case here, if you recall from yesterday, we were able to figure out the common difference when we had something that looks like this. Can we figure out the common difference with this information right there? Like we did yesterday, we added 8 plus 24 and we divided by 2. And at least people are shaking their head no, because we have 2 values here. We don't have an exact middle term like we had yesterday. But if you recall yesterday, we do want to find maybe the common difference. And actually, let's look at what we have here. We have our first value, which is 8, not 6. We have our last value, which is 24. We have our n then, which is 6. And our two formulas. Our S sub n equals n divided by 2 times a1 plus an. And then our other formula is a sub n equals a sub 1 plus n minus 1 times d. The question is, how many bricks does she need? Do we need to use this second equation? We don't need to. Now, if you look at my notes, I openly will admit I did this and then I did that. But we don't really need to. We get 6 divided by 2, and then our first term is 8, and our last term is 24. And again, we can type this in, and we get 3 times 32, which is 96. What I did is I found the common difference, and then I put these values in, and then I checked with it to see if it added up.